Let's continue our conversation about basics of geometry. This time, we will focus on something that is called segment bisector and a midpoint. Imagine this situation. Points A, K, D are collinear with the K between A and D in such a way that point K breaks AD into two equal parts. This point K could be situated that way all on its own, or could be formed by some line, or maybe its subset, cutting through segment AD at that point K. If that's what you deal with, and you do have a segment or a line just like this gray piece on my diagram, then we are looking at something that we call segment bisector. Segment bisector clearly breaks a segment into sections, but these sections absolutely must be congruent. In fact, this point at which the intersection takes place, it's K in our case, also has its own name. We call this point midpoint. Midpoint always, by its definition, breaks the segment into two parts who are equal. Therefore, we call those parts halves. And clearly, halves must be equal, and therefore, this relationship that's depicted on the diagram could be written in words as half is congruent to half. And if I give these halves algebraic values, I probably will be able to write an equation. So I'll do just that. I will use my colors to aid me identify left and right halves, and I will complete what we've just noticed. Two parts will be equal because it was given to us that way, and because they are halves. So we are being more specific about identifying the two parts that we are discussing. With the values given, we now can rewrite these relationships in words, then in symbols of geometry, and algebraically, exactly as you would do trying to make your thought process visible to people who are trying to understand this problem together with you. So, half on the left is AK, and half on the right is KD. Following up with writing an algebraic expression and finding A will allow us to find the value that represents AK and KD. Now, it is possible that you might have the same situation, but yet different. Take a look at this. I might actually have the same point K breaking the AD into two equal segments, but instead of having two expressions for the halves, I might only have one of them. But instead, I might have the value of the entire segment. In this case, I really cannot be using the relationship half equals half, even though it's true, simply because what I have on the left, 4a plus 5, will have to be equal to what I have on the right. So left will equal right, and we should know that such equation simply cannot be solved. So what do we do? Well, let's think about it and try to apply the knowledge that we already were exposed to earlier. We do have one part, and if we add the other part, it will make a whole. Only let's try to be more specific. If I take this half twice, this is how I will be then able to write it. What will be the result? Of course, the result will be the entire length. Well, it is a relationship that's based on the same elements present on the diagram, but quite different from what we had before. In a given situation, half equals half simply wouldn't work. Now, the way we've written it down probably will allow us to find the value of a. So let's continue. For a half, we will be able to substitute AK, so double AK will equal the whole, that's our AD, and therefore we can write the same fact in words and symbols and algebraically, and simply solve it for A, do the substitution for AK, and find its numerical value. Now, of course, we want this piece of information to become a part of our greater system of knowledge. It's all considered part of those basics that we've discussed earlier. Some of you might ask, what if I take this whole and simply divide it by 2? What do you think we will receive? We will receive a half left. Well, what does it mean? Do we have 2 expressions to solve the same problem? Yes, we do, is the answer. In fact, these expressions are equivalent if you look at it more precisely, and you will notice that the one on top simply was divided by 2, and as a result, we received the second one. Some of us think more in terms of dividing than in terms of multiplying. That wouldn't be me, but I think it's a beautiful way to think about things. Keep in mind, this is all additional piece of a bigger picture.